Okay, this video is all about vectors in one dimension, but here I have two dimensions, as you can see, because I want to show you what it means to have vectors in one dimension, because you're going to see it when you start kinematics, which is study of motion. You're going to see motion in one dimension, which is across a straight line or up and down across this line. Two-dimension, the classic example is projectile motion when you're shooting an object with some angle. And then you also have three-dimensional motion. Perhaps you will not cover that, but I just want you to know how you can have something that's one-dimensional, which is a vector, right? When I say one-dimensional, vector is one-dimensional, what I mean is that line is one-dimensional. It has only length. And vector, this is a vector. It's a toothpick, yes, but we're going to call it a vector for this video, okay? So a vector is basically a line. So you know that a point, for example, if you had like little boop, like a point, this is a gigantic, oh, no, I don't have a point. Anyways, if you had a little point here, dimension of a point is 0. It doesn't have length, it doesn't have width, it's just a dot. But a dimension of a line is one dimensional. So vector is one dimensional, it only has length. So how can you have something that is one dimensional in and of itself in two dimensions? Well, at an angle in relation to x and y. You have to have some non-zero angle with respect to x-axis and y-axis. So if you had 0 angle with respect to y-axis, you would be going across y-axis. You will see that motion, free fall, for example, is an example of one-dimensional motion across the vertical line, right? If you're throwing an object from some height, from a building or from a mountain, that would be a one-dimensional motion across y-axis. So here, as you can see, there is no angle between this vector and y-axis. Or you can have a one-dimensional vector going across x. As you can see, angle between this vector and x-axis is 0. It's 90 here, it's 0 here. So this is a one-dimensional vector here. Instead of going up and down, it's going right or left, or east or west. So you need to have some non-zero angle with respect to x as well as y, both. You have to have some, even if you have a tiny little angle here, that's still a two-dimensional vector. So you can have a one-dimensional shape in two dimensions. So anywhere here, let's say this makes tiniest angle with respect to y here. This is second quadrant, right? Like that's still a two-dimensional thing. You can have it in third quadrant, you can have it in fourth quadrant. So I want you to understand something. You can have one-dimensional shape presented to you in one dimension, two dimension, and three dimensions. But you cannot have a two-dimensional shape, for example, in one dimension. That you cannot have. Or you can, but then you will basically miss out on its dimensions. So what's an example of a two-dimensional shape? Well, a triangle is a two-dimensional shape, or a square is a two-dimensional shape. So because this is two-dimensional, you start from two dimensions. You can have this in three dimensions, right? You can have it at an angle here, but you can't have this in one dimension. So if I remove this, then you're only capturing the length of this square, not square, rectangle. You're only capturing the length. You're not capturing the width. So you're missing out. You're missing out a lot. Okay, so you can have three-dimensional shape, but you have to have three dimensions. So you have to have z-axis here. So I'm going to hold it down and kind of like tilt it so you can see it. So here you can have three-dimensional shape. Yes, this is an egg timer, but let's pretend that it's like a sphere or some mathematical three-dimensional shape, perfectly symmetric, nice and round. So it's coming out from this table, so the plane here, which is two-dimensional plane, it's coming out. So it has some z value here, so it's three-dimensional shape. Now, if you try to project three-dimensional shape like sphere onto 2 dimensions, you're missing out. You're pretending that it's just flat. There is no like poofiness here, right? So I wanted to show you this so that I wanted to impress upon you that vector is a one-dimensional shape, but you can have it in 2 dimensions. And you can have it in 3 dimensions. Now, we said that to have a one-dimensional vector, and vector is always one-dimensional, line is always one-dimensional, it can never be like a 2-dimensional line, right? So in the way that you can have one-dimensional vector, or simply a vector in 2 dimensions, is with having some non-zero angles with respect to x and y. Now, 3 dimensions is, again, having some non-zero. So this is a z coming out of this table, and the negative side of the z of this third dimension would be piercing through this table. So you have to imagine that. So three-dimensional vector would be either coming out of this plane, which is the table. Table plane is like this is 2 dimension. So if I have even if I just lift it up this tiniest bit, you already have 3-dimensional. Or if this vector is going through with an angle like this, you have to again imagine that, then you have 3-dimensional. So you have 3-dimensional vector if this vector has some non-zero angles here and in relation to this plane, 2-dimensional plane, which is table in my case, or x and y coordinate system on your notebook, right? So it would be coming out of your page, out of your notebook, or going into the table that you're writing on. You kind of have to imagine that, and there's always this extremely imperfect ways to draw this in 2 dimensions, on a 2-dimensional page. So now let's get rid of this 2 dimensions. Of course, I can get rid of x and do all the demonstrations across y. It would still be 1-dimensional across a line. That line, whether it's going up and down or left and right, it doesn't matter. So here, I guess I should have some 0. So let's say that this is 0. Let's say that this is 0, okay? Now, one-dimensional vector across a straight line can either go boop, boop, right, and let's name that vector. Oh, this was my name for it. Okay, I need another little. Okay, let's say this is my 0. Okay, so here it's 0 and negative x's start left of 0, per usual. So let's say that this is vector A. Let's give it a name, why not? So this is vector A, it's going east, okay? So it's a 1 dimension. It makes 0 angle with respect to x, so it's 1-dimensional. Now, you can have vector A going this way. Now you have negative A, not positive A. What negative A means, what it's telling you is that this vector is pointing opposite of your chosen positive x direction. Now, if you chose x to be going this way, to be your positive x, then this same vector would be simply A. So when you have negative in front of a vector, it's always telling you something about direction. Because vector, as we discussed in previous videos, its magnitude is length. Length can never be negative. So when you see negative sign here, that pertains to its direction. And it's relative, because depending on how I choose my positive direction, the usual direction is that x is positive towards east, negative towards west. So if I did that, then anything that's pointing west would have to take negative sign in front of it. And everything that's pointing east won't take negative sign or positive sign in front of it. We mean positive sign where there's that thing in front of vector A. So these vectors, if they're both A, that means that they have same length, but they're pointing in different directions.